My name is Dr. Yeap Ban Har, and I will share this problem with you. Spiky, he makes 3 numbers, and they are fractions. The problem is, pick any 2 and compare them. Say which one is the greater number and which one is a smaller one. Talk to your friends about this. Today, you get to choose whatever concrete materials you want to use. You have paper strips and the usual stationery, rulers, pencils, pairs of scissors. You may also choose to use diagrams, so you do not need any concrete materials. Or you may choose to use calculations to explain yourselves. Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. I wonder which 2 are easy to compare. I think these 2 are easy to compare. 5/6 and 2/3. I can compare them by making them the same type, meaning having the same denominator. 2/3. Is it quite convenient to rewrite it as a 6? That is right. 2/3 is also equal to 4/6. Comparing 2/3, which is 4/6, with 5/6, we can tell that 4/6 or 2/3 is less than 5/6. Some of us also have learned the symbol for less than. We can use that symbol. 4/6 is less than 5/6. So 2/3 is less than 5/6. We can compare fractions by making them have the same denominator. Method 2. Some of us realize that the 3 fractions are quite special. Do you also see that? How far is each of this from 1? That's right, this is 1/6 away from 1. If you can imagine the number line, 2/3 is 1/3 away from 1. And 3/4 is 1/4 away from 1. And we know that 1/6 is smaller than 1/4, which in turn is smaller than 1/3. So 5/6 is closest to 1. Next would be 3/4. Finally, 2/3. In other words, if we have a number line with 1 here and perhaps 0 here. 5, 6 is the closest to it. And then next comes 3/4, and finally 2/3. That is because 5, 6 is only 1/6 away from 1. But 3/4 is 1/4 away from 1, and 1/4 is more than 1/6. So 3/4 is further away from 1 than 5, 6 is. So we know that for the three numbers, 2/3 is less than 3/4, which in turn is less than 5, 6. So we can pick any two fractions and say which one is less and which one is more. For example, 5, 6 is greater than 2/3. Why? Because 5, 6 is closer to 1 than 2/3 is. Method 3. Some of us agree with the other two methods, but think that there is yet another way to make the numerator the same. For example, it's quite convenient to make the numerators of 2/3 and 3/4 the same. I can get 2/3 to become 6 of something quite easily. Also, 3/4 to become 6 of something else quite conveniently. In fact, we know that 2/3 has the same value as 6/9, and 3/4 has the same value as 6/8. We can now compare these two numbers quite easily. Why? Because we know that 1/9 is a smaller slice than 1/8. You need 9 of 9s to make 1. You need only 8 of 8s to make 1. So because 1/9 is less than 1/8, 6/9 must be less than 6/8. So 2/3 must be less than 3/4. This is yet another way to compare fractions. Today is a clever day. We have 3 different methods to compare fractions. By making the denominator the same, by thinking about how far each number is from 1, and making the numerators the same. I wonder which of the methods works all the time, regardless of what fractions we have to compare, and which methods work just because of the 3 numbers Spiky has made. If you understand any one of the methods well, you have learned today's lesson well. It is not possible to be able to understand every single method every single day. If you can understand one method, well done. Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Paulia, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities and exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation. That is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Scamm's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in Method 1. For average learners, they should be able to come up with Method 1 and Method 2. And if they're advanced learners in the class, Method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.